Okay, so hopefully you realize that A is going to be geometric and is going to be that you expect. So the mean is going to be 1 divided by 0.05, which I believe is that 20? It is 20 and purchases, right? Because that's what it is about. What is the probability that he does not sell one until the 8th? So this is a probability that x is equal to 8. So this is 0.95 to the 7th times 0.05 to the 1st. And again, I think that's easier to do. Point 0349. Okay, what is the probability that exactly 2 of the first 10, so this is binomial, and this is probability that x is equal to 2. So this is going to be 10 2's true, and then the probability of a success is 0.05 squared, and then it's going to be 0.05 to the 8th. Okay, now this is going to be PDF, so I'm going to go to binomial, PDF. I have 10 trials. The probability is 0.05, and I want to know about exactly 2, correct? And it's 0.0746. Okay, what is the probability that at least 5 of the first 50 buy this magazine? All right, now if I do 50 choose 5, 50 choose 5. Wow. That is 21,187,060. Do you agree with me that that is a big number? And so this is when we use the normal probability. So again, this is not going to be on the test. Okay. All right, and so in order to do this, I have to find what the z is. Okay. Okay, so this is not going to be on the test. E, if he had 280 customers that day, assuming that the day was typical for a store, what would be the mean and standard deviations for those who would buy each day? Okay, so the mean and standard deviation, you do have to know what this is, so that's 280 times 0.05 for the mean. And that is 14. And then for the standard deviation, I'm going to go to another color. So the standard deviation is going to be the square root of 280 times 0.05 times 0.95. So 280 times 0.05 times 0.95. And then you take the square root of that number, and I get 3.65 purchases. Okay. All right. Now these problems are all counting probabilities. I can't say that they're going to be at the end of the test. They'll probably be sprinkled throughout. Do you see that they want to know a subset? We want to know about 2 people. And so it's either going to be combinations or permutations. Now, because they gave these guys names, it's going to be permutations. So 7, math, 2, so that's 42 combinations. Just because I use the word combinations in the problem doesn't mean it's going to be a combination. Okay, Geraldo is creating a password sensitive on his social media. He is allowing passwords to be both numbers and letters of the alphabet. Case not important. Passwords must consist of 8 characters. How many can he have? Okay, so he says that he is allowing 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now, if he's letting both numbers and letters, that's 36. So that's 36 and 36 and 36 and 36. Okay, do you get that? 36 to the 8th passwords. Okay. There are 12 ladies on the basketball team. How many different arrangements can the coach place 5 gals on the court? So order here doesn't matter. So that's going to be 12, choose 5. So I'm going to go to my calculator. 12, choose 5, and that's 792 arrangements, okay? Okay, Schwartz is giving a 5-question true or false test. How many different quiz versions are possible? Okay, so we have 1, 2, 3, 4, 5. Now for the first questions, you have a choice of true or false. So there's 2 choices. For the second one, 2 choices. You see, 2. So that's going to be 32 different versions. All right, so you guys, remember what I said, that if you need extra help, I would do some of the problems in Chapter 17 and in the review for the unit. Okay, good luck.